Starlings Law states that stroke volume of the left ventricle will increase as the left ventricle volume increases due to stretch and a more forceful systolic contraction, which is the ventricle contracting. Therefore, more end-systolic volume, blood flowing in from the atrium into the ventricles, and more preload the ventricle's ability to stretch open and allow more blood into equals more of a stroke volume, the pushing of the blood up, which equals a more forceful contraction. And that is what the Starlings Law states. The changes of velocity in the different regions of the cardiac system. Factors that control that is blood volume, amount of blood that's in the body, blood velocity, or viscosity, which is like if the blood is thick or if it's runny like water versus honey. The length, the farther away from the heart, there's more resistance and more slower the blood. We also have the diameter, so the blood moves slower on the edges of the sides of the blood vessels. So the bigger it is, the more blood can shoot down faster, but the smaller it is, the more resistance you have, and the blood moves much slower. Also, the amount of blood the heart is pushing tells how fast the blood moves. But as far as the regions go, the change of velocity is due to the cross-sectional area. So the aorta has the least amount of cross-sectional area. It's that one tube before it starts to split off into the different atrioles or arteries. And as it starts to go down those, it's branching off into the different areas, going to the arms, going to the organs, going down to your legs. And as it splits more, velocity slows down because of all the friction. And as it reaches the capillaries, that's when you have these bundles of different capillaries, and it intertwines with the tissues, and is diffusing all this nutrients and oxygen and carbon dioxide and uptaking stuff like carbon dioxide. So it moves a lot slower through those because it's tighter, like one blood cell can move through. So there's a lot of friction going through there. It's transfusing all this stuff, and then it returns into the capillaries for the veins, and then goes up the veins where it starts to pick up more speed. So that capillaries is the highest cross-sectional area. There's so many different ways that when you cross it, there's different pathways, different frictions. So as you go into the veins, they start to fuse together. And when you fuse together, the veins start to become one, like the aorta. So the velocity is much faster, but not as fast as it was in the arteries and the aorta, because the length of the pathway is much longer. So as it's moving up, it has less pressure, and it has valves to help it out, so there's no backflow.